Hi, we're going to talk about heat transfer. You ready? You need out your Cornell notes. They should be pink for this. Um, yeah, they should be pink. And you need a pen or a pencil, unless you're going to write it with blood, but please don't. Okay, I know that was hilarious. All right. I know that you guys know about heat transfer because my children know about heat transfer. They tell me about it all the time. Conduction and convection and radiation and all that stuff. But we're going to talk about it kind of through the lens of earth science, which is kind of cool. We're going to talk about how the earth takes heat both from the sun and from within the earth and what happens to it and some cool things that happen because of it. Okay. So, kind of the big idea of what you need to know for this class, for anything doing with the earth, is that in the earth, heat is moved around by convection and conduction. Okay. Convection is the big one. We also get heat from the sun, that is radiant energy or radiation. But what we're really talking about here is the heat from inside the earth. Okay. Okay. Heat transfer. Okay. Why do we care about heat transfer? Do we care about heat transfer? Maybe you don't. I hope you're gonna. Um, it plays a crucial role in processes like plate tectonics, which is what we're talking about now, and volcanism. So it's the reason for volcanoes. It is the reason for plate tectonics. It's the reason why we don't live in Pangea anymore. It's the reason why there's this huge rift valley here. It's the reason why we have mountains. It's the reason why we don't have Pangea anymore. It's the reason why we have volcanoes. Um, all right. It changes the earth and it changes the things that live on the earth because it can change our climate very much. You know, our climate would be different if things were in different places, right? Okay. So that's why we care. All right. So, convection. This is the dominant form of heat transfer within the mantle. Okay. So we have the Earth's mantle and there is convection happening. All right. So it's driven by density. Um, so heat spreads molecules apart. You can see ice is a little weird because it has this crystal lattice structure. So, but if we're talking about the differences between cold water and warm water, or what, like a liquid and a steam, or liquid and a gas, like steam, or cold air and warm air. As you increase the heat, there's more movement. Remember, we talked about that like a long time ago in the beginning of school. Uh, so these molecules are more dense than these molecules. There are more of them in a smaller space. So that makes them sink. Okay, like I said, ice is different. Ice specifically is weird because it's it floats and it shouldn't. But that's why warm air and warm water float or rise, and that is why cold air and cold water sink. Okay, so convection is all about density. So when substances are less dense, they rise. So let's say that we're boiling some water here and we're going to have some really amazing coffee. Maybe it's lavender coffee like I had this morning. What's going to happen is the water at the bottom here is going to heat up, right? It's going to become less dense, and then it's going to come up here. It's going to rise. When it gets up to the top, it's going to heat up all of this water up here, and it's going to lose its heat. So then it becomes cool and more dense and it goes back to the bottom. Pretty cool, right? So this is happening in a tea kettle, but it's also happening inside the earth. Our mantle is liquid-ish, okay? It's not solid. Um, um, but the rock gets heated by the outer, like the core, the heat is in the core, and it comes up to the surface. The surface cools it, and then it gets more dense and it goes back down. Okay. Um, okay. I think that's what we need to know about, well, most of what we need to know about convection. Okay, what's the heat source for convection? I have this picture right here of the Martian. It's a terrible picture, but y'all remember when he had, I think that's what this is here. Remember when he was cold in his little rover and he didn't have enough energy to uh, run the heater because he couldn't go far enough on his charge. So he dug up that radioactive thing. So when radioactive elements decay, they release heat. All right. That's what this was. That's why he could put this in the back of his rover thing and be warm. Um, although I think it would have made it way too hot, but what do I know? So the decay of these radioactive elements in the mantle and in the core. Okay, so that's why the heat source is the core, because that's where the radioactive decay is happening and the heat is coming out of that. Okay. So what does that mean? Why are we talking about this when we're talking about plate tectonics? These currents are the reasons that the plates move. Isn't that neat? I remember when I kind of first learned this, and I just think it's so cool. So we have these plates, right? And we have these, this is like I don't know, it's like I mean, obviously it's a current, but it's like a roller or something, right? And we have oceanic plates, we have continental plates, and they just go, they move the plates. It's like at the grocery store, how it moves your stuff across, right? Same thing here. This moves the plates across here. It's like it's on rollers. So the mantle rises, pushes the plates apart, and then the mantle cools and it pulls the plates together. Okay, so when it's coming down, it pulls the plates together. When it's coming up, it pulls the plates apart. Let's see. I think that's all we need to know. So we have another picture down here. Here's the convection. This is calling it a convection cell. Okay, so it's going up and then down, and then up and then down. And then so here is where we are making new seafloor. Okay. So this is happening in the asthenosphere, and this is the lithosphere. And then I guess this is the crust. I think the lithosphere is, there's some kind of very specific definition for that. We don't really need to worry about it. But same thing here. We have mantle or asthenosphere. The plates are diverging. They're going apart, or they're converging and they're coming together. So that's it. Isn't that cool? I have a gift for you. Like I'm not confused, but I was. My mind was. This is X Files music, but that's not from X Files. Oops. Okay. So, we also do have conduction. All right. That is also happening. It's a secondary mechanism. Okay. So, conduction is when molecules they move heat through direct contact, like the particles touch each other and they like these hot particles excite these hot particles, and then we have a lot of heat. Um, so that's what's happening. You have to have contact. This is like when you have your pot on the stove, it's getting hot because it's sitting on top of something hot. It is less efficient than convection, but it does play a role in all this stuff. Um, because all of this stuff is touching each other, right? So that's what's happening. Let's see, what else do we need to know about conduction? Let's see. This is how the volcanoes happen, which is pretty cool. We have this down here. It gets, so this stuff, the mantle, the magma, it gets very hot and its density drops and then it goes up high, right? And so it's rising because it's hot. Okay. So that's pretty cool. I think it's really cool. That's how volcanoes happen. Oh, whoops. Okay. What you need to know is where this happens. So my notes say that mostly the solid parts of the earth transfers heat from the core to the mantle boundary all the way to the base of the crust. So I guess it's just because these are all in contact. That is why. That's the conduction part. Okay. All right. Please write a summary. Don't skip the summary. And I thought this was hilarious. It looks like Jabba the Hutt, but it's a turkey. So go make sure that you check your notes and that you have everything that I have on there. And then you can move on to the next thing in this folder, which is also probably pretty cool.